Hi guys, this is section 6.2 homework number 7. So in this particular problem, we need to show using the Venn diagram that this is equal to that, basically the distributive property, right? The distributive law for the set operations. Let's look into it. So let's take a look at the first one, A union of the intersection of B and C. So according to the order of operation, when you see parentheses, you want to do that first. So therefore, let's shade B and C, which is the intersection of B and C. So B is here, C is here, the intersection, which means the portion that they have in common. So I'm gonna shade this guy and this guy, right? That's the intersection of B and C. So that's the part one, B and C. Now that's shaded. Let's take a look at A union, what we just shaded. So union means you're gonna shade all the area included in A and also included in the region that we just shaded. So therefore, you're gonna shade everything in A, right? Shade everything in A. And also you want to shade including the shade that we just shaded. So in other words, this was shaded earlier. So all the shaded area, that should be our answer. So I'll check everything here. So that's what I would check. Okay. So check all these 5 boxes. Now let's take a look at A union B first, and then A union C, and then we find the intersection of these two unions. So let's look at A union B. So A union B is you're going to shade everything in A and everything in B. So all this blue shaded area, that will be A union B. Now A union C, let me change the color. So A union C, this should be checked, this should be checked, 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 and checked, right? Okay. Now, so A union C, the intersection means the common shaded area. That means look for the region so that we shade it in common. Now, oops, I'm sorry, A union C. So now take a look at all these. What area they're in common? Do you see that this area? Because you can see a cross and circle, right? Both shaded. That means this area, which is the same as the result we obtained from above. So therefore, okay, you can see that, right? Okay. So therefore, these two are actually equal. They're equivalent from the Venn diagram perspective. So that's how I would do it. Just follow the order of operation. Let's take a look at B. The intersection of A and the union of B and C. So let's begin with union B and C. That means you need to shade both in B and both in C, right? So that's what we see, both B union C. That's everything in circle B and in circle C. The intersection of A and what we just circled, we need to find something that's in common, right? So take a look at this is both in A and also in the region we just shaded. And this is in A and also in the region we just shaded, including that. Well, you don't wanna check this one because this is in B but not in A. You have to check the box that's also in A. So therefore, that's the result. That's the result I'm gonna shade. I will definitely erase those in my answer. That's what I would do. But I'm gonna put that back game for now. As the final answer, I'll just check these 3 boxes. Now I'm gonna look at the intersection of A and B, the intersection of A and C, and then look at the union of these two. So let's look at intersection of A and B. That means the region common to A and common to B. Okay, so do you feel like these two are the intersection of A and B, right? Intersection of A and B. You should not shade that. You should not shade that because this is in A but not in B. This is in A but not in B, right? You should not shade this. This is in B but not in A. We have to shade both in both A and B. Now let's check A and C. So A and C, that means this guy, only these two, right? Only these two. Now time for us to look at the union. Union, that means you put them together. All the shaded area we have so far. So that means these three, right? Okay, so do you see that they are the same? I should shade the same. Okay, this is how we prove that these two are equal or equivalent using the Venn diagram. Right, let's take a look at the next one. A union B, and then you find the complement. So this is the De Morgan's law. So A union B, that means I'm gonna use the blue. A union B, everything in A and in B. And then when you find the complement, you want to shade the region, not these, right? Complements, that means outside of A union B, which is everything outside. So therefore my final answer should be this one, right? So I'm gonna erase this now because we need to find the complement. So that's the complement. Now let's take a look at the this one. A complement of A, intersection of complement of B. So now complement of A, that means everything not in A. So I'm gonna shade and everything not in A. That means here and here, right? So it's outside of A. That's basically that's what we shade, these two. Now complement of B, so basically here and here, right? So everything not in B, so here and here. Now we're gonna look at the intersection, that means things in common, like the blue shaded area and the red shaded area. What's in common? That's in common because we shaded this region twice. So therefore, as a final answer, you should only shade that. You definitely need to erase those two. So do you see that they are the same, right? Last one. So the complement of intersection of A and B. So first of all, let's find the intersection of A and B. Follow the order of operation A and B, which means common to A and B. So that's the common area, which is this one. Now the complements, that means everything you should shade outside of this region. So therefore I'm gonna use my red to shade the complement of that. So I need to erase this one. Don't want to confuse you. So where I'm gonna shade everything here, these three red region. Let's say A complement, that means everything but A, right? But A, so I'm gonna shade these two. Union, okay, union, complement of B, which means that and that. Now because it's union, we should consider all the shaded area. So therefore, these three will be shaded, all the shaded area, which is the same as this one, right? So this is the little tutorial for problem number 7.